any company that makes a thing, they all have these secret robot labs. Literally robotic fingers tapping on buttons as kind of a quality control kind of a thing. And so we're kind of slipping into that kind of corner of the robotics market.
Hi, I'm Meg Nelligan. I'm the COO of Tapster Robotics in Oak Park. And what we have out here is our array of 3D printers. We use the Lulzbot TAS 5. And what you see on the printers right now is a complete printed set for our Tapster 2 robot. So this printer has printed all in the smaller parts. You'll notice the holes, and if they look familiar, it's because they're the same distance as Legos. These parts are Lego compatible, inspired by our founder's love for all things Lego. The next printer here, this will become the top plate of our robot, and you'll notice that our name Tapster has been printed on the top. At our next printer, this will become the base plate, and the mobile device or phone will sit on the bottom of the base here, and you'll also notice the holes again, Lego compatible, so that they can be locked down. And the pieces that will lock them down were printed on the first printer you saw. So we are actually printing the main pieces. We design the pieces and we print them here in our studio. These pieces will then be removed and be hand assembled into the robot themselves. The way we have this set up, we can print all of these parts in about 8 to 10 hours. We've been selling a lot lately, so I have this kit plus another 2 that are ready to be assembled. And then Jason has one of the assembled robots on his desk.
There's levels of programming it, and at the lowest level, you have, tell the motor which angle to go to. And you can build higher levels of abstraction. At some point, you can say, play this song, and then it'll figure out how to translate that into, tell this motor to go to that angle and whatever. But that's a lot of human labor that has to go into building those layers of abstraction to get from like Mozart all the way down to angles. And then even then, the robot doesn't build itself, so you still have to build it properly and tighten every screw to make sure that it's a proper kind of machine. Let's say this is warm-ups. Any robot or human, the first time you start getting to the keyboard, you're a little rusty. So it's been a while since I've actually run this demo. I need to calibrate it a little bit. But the demo that I've had is basically doing kind of a duet of Heart and Soul, as the cliched first song that anybody, if you see a piano, everyone's going to do that or the Jaws theme, right? And then if I've got my own phone, I can kind of do a duet with the robot, right? If I need it. I forgot the rest of it. Pin art, or pin screen, is the name of this desk toy. And it's this array of pins, either metal or plastic. You put your face in it or hand in it. The idea was, what if you could motorize every single one of those pins? And so one of the things that I've been trying to figure out is how to do that from a software point of view, from mechanically how to make it move, and then also the electronics. And so this is actually the prototype for one of those pins. And the idea potentially is to have a huge array of them, and so you can do have an infinite number in any direction, and either be something on the wall, have a display of all these motorized pins, or potentially have a desktop of them, and you can do things have Grand Canyon show up, or downtown Manhattan or something. So the trick is okay, how do I actually do it? And so I do have this one particular prototype wired up with a motor, and basically the fancy word is it's a linear actuator, but it's because it's 3D printed and I have my own custom electronics for it, I'm driving down the costs for it. So very simple, version 1 kind of a thing is that it can kind of go up and it can go down. And the trick was making it actually reliable. I've been adding these springs and just making sure that it doesn't get kind of stuck in each direction. Some future version I'll have to figure out, okay, now that I've made one, how do I make 10,000 of these things? That's the next trick. And the other thing is this is it really hasn't become a product yet. It's more of still just an art project. And so what I'm kind of doing with Tapster is that as we sell robots for testing and selling these to companies for testing their phones or applications, I'm hopeful, I'm learning the same skills that I need to
complete the art project and using it in the robots that we sell to companies, and then also hopefully at some point, the revenue, the profits from the business robots that we sell, I can kind of put into completing the art project.
We've done educational workshops, so we've brought in kids with their parents for a couple of hours, and again, the same idea that we print all the parts ahead of time, and then the kids assemble. So this, for example, this is the head of the robot, and this groove here sits perfectly. Sorry, I'm moving this too fast. Fits perfectly on top of the servo or the motor that is moving the head and the top of the robot there. So the dance spot it's fun, and it's a great educational tool. But we've been wondering what can we do with it as a company. So Jason got the idea of is there a world record for how many robots were dancing the robot dance? And in fact, there was no record.
That was exactly a year ago, February. But since February, the record was set around a month later by a company in China, and then 6 months later or 4 months later, whatever it is, the math is, in July, another company, a different company in China, broke the record, and so now the record for most number of dancing robots all in one place is 1,007. Twice in a year it was set and then now broken. But anyway, so when the original record wasn't the record at all, the table stakes to get a new record in a new category is 50. So I can totally do that. But now that the record is 1,000, we're trying to figure out how to pay for it.
We want to do it though.
Right. So the idea potentially is.